Hello, Math 3 students. We are in the 5th week of the second term, and so next Friday is the last day of the second 6 weeks. Normally, I do this unit a little bit faster. I go through rational expressions a little bit faster, but I want to go slower this time because because everything is remote, everything is on the computer, and I'm not standing in front of you teaching and helping you with classwork, so I wanted to go a little bit slower. We're going to just slow down today and review everything we've done so far from last week and this week, and also your test on this is this Friday, and it covers this week and last week, so it covers everything we've done with rational expressions is going to be on this test this Friday. And then next Friday there will be a quiz, and that will be the last grade of the 6 weeks. So this PDF includes simplifying, multiplying and dividing, adding and subtracting, and complex fractions. And the complex fractions in this particular video have some adding and subtracting in them. So we'll be combining those skills to do those complex fractions. All right, let's get started. I'm going to work all of these, and I expect you to work all of them as well. If you are working on your PDF, you might want to enlarge it a little bit so it's easier to write, because it's really hard to write that small sometimes, and I'm going to do the same. So I actually just enlarged mine to 300% because I think this provides the best view and the most room for me to write. Okay, so this first one is simplifying, and if you remember, in simplifying rational expressions, we have to factor first. So the first thing we want to do is look and see if we can take out a greatest common factor from either the numerator or denominator. So we want to factor the numerator and the denominator first. It's not multiplication of rational expressions or anything like that. It's just simplifying them. So let's look at the numerator first and see if we can pull out a greatest common factor. We can. And the greatest common factor is going to be 6x squared. And the way I knew that is, first of all, look at the coefficients. The coefficients are both 6, and then the x squared is the smallest exponent between the two terms. And so then I have parentheses, and 6x squared divided by 6x cubed is x. 6x squared divided by 6x is 1, so I have a plus 1 here. And then my denominator, I'm going to take a 2x out of that, and I will have x squared minus 1. Okay, so this part right here is not completely factored. So I still need to finish factoring this. So I'm going to write equals one more time. Numerator, I'm going to bring over what I already did because that one's factored as much as it can be. And then the denominator, right, my 2x. This, what I've highlighted in blue, is difference of two squares. And so that factors to x plus 1 and x minus 1. The square root of x squared is x, and then the square root of 1 is 1, and so this factors into difference of squares. Okay, so now what can I mark out? Well, let's see. I have an x plus 1 here and here. Remember, it has to be numerator and denominator. You can't do two terms in the numerator or two terms in the denominator. It has to be, one has to be over the fraction bar, one has to be under the fraction bar. I can look at the 6 and the 2. I can do the coefficients. Let's divide by 2 here. Divide that by 2, you get 1. Divide that by 2 is 3. Another thing that might make it easier is if you like completely mark out what you factored, and then you're not like mistaking anything and including anything in the answer that shouldn't be there. I also have an x and an x squared. The x divided by x is 1, so I don't need to put anything down here. X squared divided by x is x. All right, so I have canceled out all the factors that I can, and so what I have left in the numerator is 3x, and in the denominator, x minus 1. This is my answer right here. So number 2 is a little more complicated because I have two trinomials, numerator and denominator are both trinomials, and neither one of them has an a value. In other words, this and this are the a values. If the a value is 1, it's a whole lot easier to factor, of course. If it isn't, then we can look for a greatest common factor, but there is no greatest common factor in 4, 12, and 9. Greatest common factor is 1. And the same thing with the 2, the 15, and the 27. There's nothing I can take out of there. So what I need to do, I'm going to erase this stuff that I just did. There. So what I'm going to have to do is factor each of these by splitting the middle term. So I'm going to end up with numerator and denominator factored. So I'm going to end up with 2 binomials in the numerator and 2 binomials in the denominator, but I have to work with them first. So let's see, I've got 4n squared, and then I'm going to split the negative 12 into 2 terms plus 9. So I'm going to work with the numerator first. So this is what I'm factoring right now down here in purple. The 4 times the 9 is what I have to do first. 4 times 9 is 36. And then I've got that negative 12 as the middle term. So I need a factor pair for positive 36 that when I combine them I get negative 12. And that's going to be negative 6 times negative 6. Negative 6 plus negative 6 is negative 12. So this is going to be a minus 6n and a minus 6n. Okay, so now I'm going to separate these into 2 groups, and the first group the 4n squared minus 6n, I'm going to take out a 2n. I'm going to factor that, and that's going to be 2n minus 3. Okay, and then over here I need to end up with a 2n minus 3 in the parentheses, so I'm going to take out a negative 3. Okay, so negative 6n divided by negative 3 is positive 2n. Positive 9 divided by negative 3 is negative 3. So remember, we want to look and we want to make sure that this and this are the same. So that, what I highlighted there, is the first factor. And then the second one actually happens to be the same. It's what's left over. So that's what goes up here. 2n minus 3. 2n minus 3. Okay, now what I have to do is I have to factor this one in the same way, but I'm going to save us some time and I'm going to go ahead and tell you what it is. It is 2n minus 3 and n plus 9. So we would have factored this exactly the same way we did the other one, the 2 times negative 27 and so on, but I'm just going to save us some time. Okay, so what can be marked out? I've got a 2n minus 3 here and here, and then that's it. And what am I left with? 2n minus 3 over n plus 9. Okay, so that was our simplifying. Let's move on to multiplication. Okay, multiplication, we don't have to flip anything, we don't have to rewrite anything, we can just start factoring. So I'm going to have, let me see, I'm going to highlight some stuff here so you know which ones I'm talking about. Do blue, whoops, do green, orange, and purple. Okay, so maybe that'll make it a little bit easier to see what I'm talking about. I don't have a black anymore. There we go. It's supposed to be black. Okay, so now let's factor the blue part. 42a squared minus 24a. I'm going to take out a 6a, I think. Yep, 6a. That's going to be 7a minus 4. Okay. The green on the bottom, let's take out 3. That is going to be 7a minus 4. So there's something I can cancel already. The orange part, 3a minus 9. Take out a 3 there. That leaves a minus 3. And then the purple part. Let's see, what can we take out of that? A 6a. What does that leave? A plus 4. Okay, so now we can start. Oh, we can cancel a lot of stuff out. This is a nice one. All right, so what can we cancel? I have a whole 6a and 6a there, a whole 3 and 3 there, 7a minus 4 there. So what am I left with? A minus 3 over a plus 4. Okay, so every one of these we just took out a greatest common factor. So you look at the coefficients, take out the number that they have in common, the common factor they have in common, and then you look at the letters. And so like with this one right here, the a squared and the a, well, this is an a to the first. It's always just going to be whatever the smallest one is. So on that one, it was a to the first. If it was Just give you an example. If it was like an a to the 4th and an a cubed, it would be the a cubed. It's always just whatever the smallest exponent is. That's the greatest common factor. Okay, number 4. Let's see. Okay, let me highlight these two. I think that might make it easier. That's a difference of squares. This can't be factored. This I can take out greatest common factor. And what other color? Orange. And this is a trinomial that's going to end up 2 binomials. Okay. I'm going to put this down here. So I'm going to factor them first. Remember, you got to do that. You got to factor first when you have a multiplication problem, because you can't start canceling stuff out until you do that. Like you might see, okay, oh, here's a y squared right here and a y squared down here in the denominator. You can't factor that. I mean, you can't cancel that until you've factored everything. Okay, so the purple one is a difference of 2 squares. The problem is they're kind of what I would consider backwards. So 49 minus y squared. I would rather write this y squared minus 49 and take out a -1. The reason being that I've got this orange part down here that I think maybe it will have like a -7 in it. So I'm going to do it like this. I'm going to do -1 and then y plus 7, y minus 7. Okay. My teal part or light blue part, whatever that is, that one can't be factored, so I'm just going to bring that down, 48y cubed. All right, the green one. The green one, I can take out a GCF. So this one was difference of squares. That's not a square, that's a square root, but whatever. This one is take out the GCF. And then this one is a quadratic or a trinomial. So 3 different factoring methods. All right, the GCF one, let's take out 6y. What have I got left? Y plus 7. Okay. And over here, orange, let's see, 21 and -10. That's 3 and 7, -3, -7. So this is y minus 3, y minus 7. Yep, and I thought there might be a y minus 7 somewhere. All right, let's cancel some stuff out. Let's cancel this y plus 7, the y minus 7. I can also do this y right here and the y cubed. That's going to be a y squared. I can also do the 6 and the 48. Divide by 6. And that's going to leave an 8 up here. Okay, so I'm going to just like really mark out everything that I canceled. That way I can see a little bit better what I've got left over. Okay, -1 times 8y squared is -8y squared. And then the denominator, I have y minus 3 left. Okay, so be careful when you get to division problems, because you remember you have to rewrite the whole thing. And, oh, I don't want that color. I want to do this in black, because all I'm doing right now is rewriting. So then I need to change the division to times, and then flip the second fraction. Okay, now I'm going to color code everything. This is a difference of squares. This is one where the a value is greater than 1, so I'm going to give you that one. This one is a value is 1, so this one's a lot easier to factor. And what do I need? Green. This one, a value is 1, easier to factor. Okay, so what I want you to do, I'm going to give you the purple one. And then I want you to try to factor the other ones. The purple one is 4w minus 1 and w plus 9. So that was the purple. I want you to pause your video and try to do the orange, teal, and green ones. Try to factor those. The orange one's a difference of squares, and the other two are find your binomials. You got your binomials, and you look at the last number in the middle term. Okay, so this is what you should have come up with when you factored the other 3. And we're going to start marking some stuff out. Let's see, I have a W plus 9 there and there, W minus 9, W plus 4, and I think that's it. So what do I have left? W plus 7, oh, I made a mistake. This should have been a W plus 7 down here. So that would have meant my W plus 9 would stay. So the W plus 7's canceled, and this makes a W plus 9 in the numerator. And then my denominator is 4W minus 1. All right, let's see if we have another division one. Okay, so let's rewrite this one. Times, okay, so this is, you can put anything over 1. So this is this over 1. So that makes my numerator 1, and my denominator, I'm going to go ahead and take out a 2. That leaves me, actually I'm going to take out a 2c. That leaves c squared minus 6, oops, not 16, sorry, minus 8c plus 12. So then that part can be factored. This part right here can be factored a lot more easily. So that one can be factored, and this one can be factored, taking out a greatest common factor. I want you to pause your video and finish this one completely and then come back. Okay, so we rewrote this one together. The orange part, I factored 30c squared out of that and got c minus 2 in the parentheses. The green part, I factored c minus 6, c minus 2, and that I did have those in both the numerator and denominator. And then the 30, what I did was I factored the 30 with the 2 first. And so that gave me a 15, as you can see right here. And then I did the 15 and the 3, because you can factor more than one or cancel more than once if you need to. So then what I had left was 5 over c minus 6. Okay, so now we're into adding and subtracting. I might possibly leave out 1 or 2 of these, and I'm probably only going to do like 1 or 2 of the complex fractions also. Okay, so yesterday we went into adding and subtracting, and it's a little bit, I guess you could say, more difficult if the denominators are different. The denominators here, as you can see, are the same. So it makes it a little bit easier when they are. So all I have to do is bring over the denominator and then add together the numerators. Now in the numerators I have some like terms. I have 17k and 3k. I also have 3 and 7, so I can combine the like terms, and that's going to be 20k plus 10. I'm not quite finished because both of these, the numerator and the denominator, can actually be factored, and I can simplify this. So the numerator, I'm going to take out a 10. The denominator, I'm going to take out a 4. I did the top backwards. What's in parentheses is wrong. It should be 2k plus 1, which means it can cancel there. And then the 10 and the 4 I can divide by 2. So my answer is 5/2. Okay, so number 8 is subtraction. So I think what I will do is I will change this to plus and then change these to their negatives, to their opposite first. The denominator is the same, so I'm just going to bring it over. And I will factor it later, but I don't need to factor it yet. 9m minus m is 8m. Negative 12 minus 28 is minus 40. So now I can factor. So the purple, I'm going to take out a greatest common factor. going to take out 8. The denominator is a difference of squares. Okay, so that's how that factors. I can cancel the m minus 5. My answer is 8 over m plus 5. Just be careful if you have a minus here, it's minus the whole thing. So you have to change both of these to the opposite. And we've done that when we did polynomials. I'm going to choose one of these to do, no, we'll go ahead and do, we'll definitely do 9. Okay. So let's see, for 9, I've got 2 different denominators. So what I need to do is determine what the least common multiple is. 12 and 24 have a common factor. So what I can do is I can rewrite the 24 as 2 times 12. And that way I can say, okay, they have the 12 in common. Those are the same. But the y and the 2 are different. So over here on the right side, I need the orange. So I'm going to multiply times the orange over the orange. If you remember doing this yesterday, this is going to be familiar with you. And then on the left side, I need the purple. Okay, so what were those numbers? The purple is 2, so I need to multiply times 2 over 2. The orange is y, so I need to multiply times y over y. Now let's rewrite this whole thing. So 2 times 3 is 6. And that's over, and we can write 24y here. And then plus 9 times y is 9y, and that is also over 24y. So now I can combine those, 9y plus 6 over 24y. I'm not quite done though. What I need to do now is factor again and see if I can cancel anything. Okay, so for the numerator, let's take out a 3. That's going to be 3y plus 2. And then the denominator is still just 24y, but the 24, and I mean, you can think of these as 2 different factors. The 24 and the 3 can cancel. Divide that by 3, divide that by 3, that's 8. So then my answer, 3y plus 2 over 8y. Now, let me look at number 10. Yeah, I think we'll go ahead and do number 10. We'll leave out 1 or 2 of these. First thing I want to do is factor everything, okay? Because I gotta look at the denominators and see what they have in common and what I need to do differently. And I'm going to do this down here. Actually, I only need to factor the denominators first, so let me do that. And that's going to be, I'm going to do plus -4. So I'm going to leave this. Doesn't really do me any good to factor that. I'm just going to factor the denominators. All right, so the denominator on number 10, on the first one, it factors to p minus 9p plus 3. Okay, let's look at the denominators. What do they have in common? Well, they both have the p plus 3. And then what do they have that's different? Well, one of them has a p minus 9. So the least common denominator is the orange times the green, okay? So both denominators need the orange and the green. So the one on the left, it has both of them. So I don't need to do anything to that one. But the one on the right, it doesn't have the orange. It's missing the orange. So I need to multiply that by the orange over the orange. And if you remember from yesterday, what I'm really doing, the orange was p minus 9, is I'm multiplying times 1, because p minus 9 over p minus 9 is 1. But I'm getting the denominator the same, so then I can add these 2 things together. So now I just need to rewrite it one more time, or you know what I can do? I can just do this numerator over here. So -4 times this is -4p plus 36. Okay, so now what I need to do is this. I need to add the numerators together. Okay, so I've got some like terms. I've got a positive 2p and a negative 4p. And then let me get a different color. I also have a negative 31 and a positive 36. The p squared It's kind of by itself because there's nothing to add to it. All right, so now I'm going to add the like terms in the numerators. P squared minus 2p minus, what is negative 51 and 36. 15, negative 15. Okay, and that all goes over that common denominator of p minus 9, p plus 3. Okay, so now I want you to forget everything we did at the top and just look at this expression right here, this rational expression. All right, so just look at this. Forget everything we just did. I mean, you need to know how to do it, but don't worry about it anymore. Now what I need to do is simplify this. Okay, so when I simplify, I have to factor both the numerator and the denominator. When I factor that numerator, that's going to be p minus 5p plus 3. Bring over the denominator because it's already factored. Okay, what can be marked out? The p plus 3 can be canceled. My answer is this. And that's a minus 9. It doesn't look like it. There we go. Let's do 12, I think. 11's pretty easy too. We'll do both of them. Okay, so on number 11, I have an r plus 6 and I have an r. Well, they don't have anything in common. So the least common denominator is going to be the red times the teal or the blue. So this side needs the blue and this side needs the red in it. Okay, what are those things? Well, the blue was r, so I need to multiply times r over r. And then the red was r plus 6. All right, and this is a minus right here, so I'm going to change that to plus negative 1. Okay, so now I'm working with each of these things separately. So I'm going to do this right here, and then I'm going to do this right here separately. So they have the same denominator, so I'm going to just rewrite the denominator. Then I'm going to multiply r times r, that's r squared, and negative 1 times r plus 6, oops, is negative r minus 6. Okay, now I have my numerator. I'm going to add together everything in my numerator, and my denominator stays the same. Well, when I add together everything in my numerator, there aren't any like terms. So this and this and this, there are no like terms. So all I can do is just write r squared minus r minus 6. I'm not quite done. So again, just like a while ago, I only want you to pay attention at this part and simplifying it. Okay, so how do we simplify a rational expression? We factor everything. Let's factor the numerator. The numerator factors to r minus 3, r plus 2, I think. Yep. Okay, well, on this one, there happens to be nothing that I can cancel out, so this is my answer. Looks a whole lot more complicated than the one we started out with, but anyway. All right. I think I'm going to skip 12. Mark that one out. Okay, so we have a few complex fractions. I'm going to look at 13. So if you remember from the other day, this right here means divide. So I'm going to rewrite this problem, oops, as a division problem. 15x minus 10 divided by x minus 8 divided by 3x minus 2 over x squared minus 12x plus 32. Now I need to rewrite it as a multiplication problem. Don't do anything else except just rewrite it. Make that times and then flip the second fraction. I wrote that wrong. That should be minus 12. Next step is factor, if you can. Okay, let me color code these so you know which part I'm talking about, because the cursor, it doesn't point to anything when I'm working on this. That's why I color code everything. Okay, the red part, I can take out a 5. The green, I can't do anything to it. Just going to rewrite it. The teal, that factors to x minus 8, x minus 4. The purple, I can't factor that. So I just rewrite it. Okay, so now I can cancel stuff. The only thing I can cancel is this, I think. Oh, nope. I see where I made a mistake. This should be a 3x minus 2. Because when I took out the 5, that would be 3x. 15x divided by that would be 3x. Okay, so I can mark out this 2. Makes it a little bit easier. In the denominator, I'm left with 1, so I don't need to write anything for that. I can just write 5 times x minus 4, and that's my answer. Okay, we're going to look at number 15. And I want you to be really careful with this because this is a complex fraction, but I don't want to rewrite it first. I really want to work with both the numerator and denominator and get that so that there's no plus or minus in there, because if you notice, this is a subtraction problem, and this is also a subtraction problem. So I just want to keep that fraction bar for now and just work with the numerator and denominator until I don't have a plus or minus in either one of them. All right, so let's look at the red part, and I'm just going to work with it down here. P squared over 5 minus 20 over 1. I need a least common denominator, or I need a common denominator. Okay, so I've got a 5 and I've got a 1. Well, the easiest way to do this is just to multiply this one on the right times 5 over 5. So what they don't have anything in common, but because I have that 1 right there, I don't really have to pay attention to that. But I do need a denominator over here that's 5. So the way to do that is to multiply this fraction times 5 over 5. Okay, so when I do that, the first fraction is still p squared over 5. The second one is minus 100 over 5. Okay, so my denominators are the same. And remember, I'm still only working with this numerator up here. So I'm still working with this right here, right now. And then p squared minus 100. I'm just going to leave it like that for now. So I've got my numerator, p squared minus 100 over 5. Okay, so I'm done with that part. Now I need to look at my denominator, the p over 10 minus 1. Well, 1 I can rewrite as 10 over 10. Actually, let me do purple. If I rewrite 1 as 10 over 10, that means my denominators are the same. So then I can just do p minus 10 over 10. All right, so now I have a complex fraction where I've just got a rational expression in the numerator and a rational expression in the denominator. So now I can work with this. See if I can get rid of this down here. There we go. Now I can work with this and rewrite it as a multiplication problem. First thing I'm going to do though, I'm going to rewrite it as a division problem. There. Now I'm going to, on the next line, I'm going to rewrite it as a multiplication problem. P squared minus 100 over 5 times, and then I'm going to flip the second one, 10 over P minus 10. Okay, so now I've got a division problem, pretty easy to work with. This part right here is a difference of 2 squares. Nothing else can be factored. So I'm going to rewrite the purple as P plus 10, P minus 10. This part right here just gets rewritten. And this whole thing just gets rewritten also. Now I can cancel stuff. I can cancel the P minus 10. I can do the 5 and the 10. That's going to be a 2 right there. So everything in the denominator got canceled. So my answer is going to be 2 times P plus 10. Look, I know this is complicated, and I'll try not to give you maybe like one of these on the test, but, and also I'll go through some during the live lesson as well. Let's see, I think for now we will leave 14 and 16. So here's what I'm going to do then. You're still responsible for doing these. I will be working these two problems during the live lesson. So I'll work those during the live lesson. You come to the live lesson and you'll have these worked for you. And let me see, was there another one up here? Yep. I'm going to work number 12 during the live lesson also. All right. So that was 37 minutes. I think that's enough.